Here we're talking about scales. We're going to be using proportions and they're going to be in story problem form. We talked about scales with shapes, so now we're going to do story problems. So we can say scale models and scale drawings represent objects that are too large or too small to be drawn or built at actual size. So examples could be blueprints. So blueprints are like graphs of buildings that haven't been built yet. Maps. Maps are a much smaller version of the roads and cities, states, countries. We could say model cars or airplanes because obviously they're much smaller. Children typically play with these or adults collect them. The scale gives the ratio that compares the measurements of the drawing or model to the measurement of the real object. So it'll say like how many inches of something will equal how many feet in real life or something like that. So all the problems we're looking at today already give us a scale. At some point we are going to look at problems where they don't give us a scale, but we can still figure out what the actual distance would be or the distance of the smaller measurement. So what you're going to do is figure out what's the scale. So here it's 1 centimeters equals 24 miles, and we're going to write that as a fraction. So 1 centimeter over 24 miles. And it's really important that you write the labels with these. The only other number that they tell me is 4 centimeters. Since that's centimeters, I'm going to put it on the same part of the fraction that I put centimeters in the first fraction. So in the first fraction, centimeters was on top. So in the second fraction, it's going to stay on top. And then I don't know how many miles, so I'm going to put M for miles. So we have our proportions set up, and we already went over how to solve these. You cross, multiply, and divide. So you multiply the numbers across from each other. So 24 times 4, which is 96. And then you divide by your other numbers. So divided by 1 is still 96. Now you need to look back. You were trying to figure out what M was, and M stood for miles. So it's going to be 96 miles. So always make sure with story problems we have a label. Number 2, a graphic artist is creating an advertisement for a new cell phone. If she uses a scale of 5 inches equals 1 foot, what is the length of the cell phone on the advertisement if the actual cell phone is 4 inches long? So again, your scale is going to be your first fraction, so 5 inches over 1 foot. Then the only other number I know is 4 inches. Since I had inches on top here, I'm going to keep inches on top over here. So I don't know how many feet the length of the ad is going to be. So we cross, multiply, and divide. Multiply the numbers diagonal from each other. So 1 times 4 is 4. Then you divide by the other numbers. So divided by 5. So 4 divided by 5. 5 doesn't go into 4, so we put 0 in a decimal. And now it's 0. 5 goes into 48 times. So it's 0.8. And I look back, I was trying to figure out F, which was feet, so 0.8 feet. Also, always make sure that your answer makes sense. If 5 inches was 1 foot, and they said 4 inches, obviously it's going to be a little bit less than 1 foot. Okay, last problem. On a blueprint for a new building, the scale is 3 inches equals 7 feet. I want to know the actual height of the building. On the blueprint, the height is 10.5 inches. So we are going to write our scale first. So 3 inches over 7 feet. And then the only other number that they told me was 10.5 inches. Since it was inches and I had inches on top here, it's going to stay on top here. So I don't know how many feet. So I'm going to cross multiply. So 7 times 10.5, and that is 73.5. And then you divide by your other number, so divide by 3. and you are going to get 24.5. It said round to the nearest tenth, but it already went to the nearest tenth, so that's fine. I look back, I see that it was F for feet, so 24.5 feet is going to be your answer. Okay. If you have any questions, please let me know.